Hi. Good evening, everyone. Good afternoon. Yeah, still 3:46. Hope you are not bored with this topic of talking to your data with your natural language and all, because from morning, most of the talks is related to that. In today's talk, we're going to talk how we have implemented this at GitLab in terms of using natural language with Snowflake Cortex in terms of enabling our end users who are not basically the business analysts, but those who are able to write it and execute it using just the prompts over there. So with this, there, yeah. Okay, there was a disclaimer slide, but we move to this. So about me, I work as a staff data engineer at GitLab, been there for over 4.5 years, and in the last 15 years of my experience, I've seen that a data team has moved from the back office to the front line. And as an organization, GitLab thrives in terms of we believe everyone can contribute, and innovation do not comes by working in silo. It works when we are working together as a collaboration, which breaks by breaking the boundaries across the team. So that's why our mission is that everyone can contribute to make something better and big. At GitLab, so the question is, what is GitLab? And the GitLab is a DevSecOps platform delivered as a single application to help you iterate faster and innovate together. It means that this is one platform integrated for the whole CI/CD along with your code repo and your documents and everything along with that. I am part of the data platform team, which is a part of the central data team at GitLab. And the way the data organization at GitLab works is we have a central data team, which includes analysts and a data platform, data engineers like me, one of my colleagues sitting over there in the crowd, him. And we work in a hub-and-spoke model where we've served different streams, which is people ops, sales, marketing, the all different domain across the GitLab as our stakeholder. Those are our end user and as customer. And as a platform team, we are responsible to ensure that the infrastructure is scalable and reliable and resilient to support all the business needs of GitLab end users, basically. So with this, let's get started. One question which is coming, why this talk, and why everyone is talking about this conversational analytics, which I say, or talking using natural language to talk to your data, is that today process is very slow, is inefficient. End users keep raising tickets if they need a certain dashboard. To build a dashboard, we have seen that it has moved from like 3 weeks to 1 month, or maybe a week at least, to get it ready for them to see, and then they have to validate, is the answer correct? But still with that, it comes with limitations, that it is a predefined requirement. You don't have something which is open-ended and you can dig up more and more. If it is once dashboard is there, you can go drill down a little bit more using Tableau and all, but there is a limitation to that. So how do we go from dashboards to dialogue? And that's the challenge which we are trying to solve, is that traditional BI versus conversational analytics. How do we do the conversational analytics instead of having a traditional BI where we have a set of dashboards which takes a longer time? And in this, if we look, we have a different aspect about this, is that the interface in the traditional BI used to be charts and filter, but in conversational analytics, in terms of Snowflake, it's Cortex, is a natural language. Always in traditional BI, it was a dependency is on analysts, rather than in new world, it is a self-served, it's an independent entity. Latency used to be like hours or days. As I said, it used to take weeks. Earlier, it used to take 2 months, but now we have improvised, we have automated. It takes still few days to get a dashboard up and running. And now it has gone to seconds because you have a platform where you can just go and ask a question. You don't have to wait for an analyst to give an answer to your question. Flexibility, as the conversational analytics is an open-ended, where you can ask question and go deeper and deeper till you get a satisfied answer. Whereas In the old world, it is a predefined, and if you have to put a new requirement, you have to iterate on top of it. You have to say, I need more of this information. Can you bring this data as well? And then the analyst will go and rewrite your models and bring that data for you to do. So how to solve this limitation of traditional BI? What is the solution? So we solve it at GitLab. We did use it using a Snowflake Cortex. And that's the tool which is provided from Snowflake to use it. And what is a Snowflake Cortex? It's a suite of built-in AI/ML capabilities in a Snowflake, which helps you or enables you to use, which helps you to translate your natural language, your queries, to a SQL and gives a result back without a user to have a deep knowledge or any knowledge about the SQL. But it also gives you a SQL in order to you want to verify it. It is natively run within a Snowflake, within the secure compute plane. And that's one of the biggest advantage, that your data never leaves your horizon, your premises in a Snowflake. Because with AI, one biggest challenge what we face, that if we give an open-ended, we point Anthropic or any of the models which is outside and we connect it to a Snowflake, the data leaves a Snowflake. And that makes us vulnerable in terms of who is accessing it and what is happening with that data. So is someone downloading it, where there is no control what questions have been even asked. And that's where, since it runs natively in a Snowflake, it helps to make the data secure and governed. So in this slide, which believe you have seen this slide in a couple of other Snowflake talks, but just to be on the same page over here. The data comes from different sources, like using different data connectors. We have OpenFlow coming from Snowflake itself, but we use at GitLab heavily Fivetran and Stitch. And we have our own custom connectors, which is extensively used and developed by us. And it brings data from the Snowflake marketplace. We use a lot of data sharing from multiple different data sources like Zora and all. We use their data to bring it into Snowflake rather than having a custom API to do this. And then the processing of this data, our focus will be Cortex Analyst in this one. But we have a Cortex Search, which works a lot on the unstructured data sets. Analyst works very good on the structured data retrieval. And that's what we used. For document processing, we have Document AI and all. And then on the top, you have the agents and insights, which is a Snowflake offering of Snowflake Intelligence, which is an integration layer for the agents of all this processing and retrieval process. You have agentic apps and Cortex app agents, they call it, and then Cortex AI SQL, which is a multi-model AI-powered SQL. But on the right-hand side, on the extreme right, when we talk about governance, that's the key factor across all of these layers of data, processing, retrieval, and agents and insight, that it is always governed. People who don't have access to the data, they can't even through the AI say that I want access to a HR data, for example, and what is the salary of an employee, if they are not allowed to. If they are not in that list or in that they don't have that particular roles, even through the Cortex, they won't be able to do that. So those things are governed. It's always on a monitoring, and we have a proper monitoring and AI gateway, which helps us to keep our system much more secure and reliable. Coming to the Cortex family, that's what I call it. It has lots of things, so that's why a family does not contain of just one Cortex. It's a Cortex Complete, which works with LLM interface for text to SQL or summaries. For example, in a normal SQL statement, you can select and say Cortex Complete and summarize the quarterly sales, and you target your table, and it will do the job for you. You have Cortex Search, which works with unstructured data sets, which is using vector search for embeddings, and it is a semantic search on documents, PDFs, like that. You have Cortex Analyst, which is for a structured data sets, which is for natural language analytics on the data, and which is what we have used. Cortex Classify is a text classification, a label support, like supporting, you have support tickets which comes from Zendex, and you want to label them that which one is P1, which one is P2, or different label you want to add. And then we have Cortex Embedded Text, which is for generating embeddings. It's a built vector for retrieval. So Cortex Analyst is what? It provides a chat interface to query a structured data. It uses semantic model, which is built and defined in YAML for trusted text to SQL generation. Integrates with RBAC, that is a role-based access control, governance, and monitoring, and available via Snowsight and REST API. This is something at GitLab, what we have built is that we have built an Streamlit application on top of our semantic model, pointing to that semantic model using Cortex Search. And that is the interface which is exposed to our end customer. So Cortex Analyst as such is a answer data questions like you're messaging a colleague. It's simple prompts. It's industry leading in accuracy. No coding is needed. Always up-to-date data because the data sets in your warehouse. It's not leaving data sets. And enterprise-grade security which comes out of the box from Snowflake. The reason for us when we started implementing this was business user asks natural language questions. They don't have to be aware of SQL. And in our case, the business user in the last talk you heard from Google, that it can be a manager who is not aware much of SQL and not have a huge expertise on SQL. The Cortex analyst is responsible to translate them into a governed SQL, whatever the prompts and whatever the requirements being fed, and execute it securely and return the trusted insights. With this, we'll go and dive in and see that how does this Cortex analyst actually work. So user asks business questions like, for example, summarize the sales for this particular store, or how a particular product is working at a GitLab, for example. The semantic model determines if the questions can be answered, and if yes, we generate this query and provide the answer. So in this case, based on the semantic model you do, it is able to generate a query, run it against your database based on your role-based access, and then give an answer. And if no, then it provides alternative question and then asks for repetitive prompts. It gives a graceful error as well, saying if you don't have access to our data, that's the way we have built it. And this, if you think as Cortex analyst, it's like bridging the data and language. What is the total revenue of this month? That's a simple question. And the Cortex analyst is the brain sitting in mid, which is writing the query, hitting it to the database, and giving it back to this, to the user. It's runs the trusted SQL query, and that can be validated. User is able to see, they can pass it to an analyst, can you check this query if required. It has happened with us that we have got the output back to see that this result looks good, or this is not looking good, and can you check the query which is executing. So in terms of how the analyst works, we set up the semantic view. The admins in the Snowflake, like in our case, it's the data platform engineering team. We build the semantic view using the Snowsite provided semantic model generator, which comes through the UI. Earlier, when they launched it, it was done mostly through a manual task where we were using an external application to generate the semantic model for the table. The end user asks questions on a natural language, and Cortex Analyst uses the question and the semantic view both in collection to generate the SQL. And a semantic view, we are talking about, we call it different thing in different landscape, like a different company calls different. And in the Snowflake, the semantic view in Cortex Analyst is a mapping between business terms and underlying data models. Like example, the logical tables, that's the first thing, represents the business entities like customer, products, product time, date, and location. It contains fields like dimensions, product time dimension, customer region, and all. Facts, all the item price, the basket, the whole thing. Metrics and filters, so it also defines that when people says that what is the revenue, it can be able to do the sum of all the revenues. That's an expression, that's a mathematical term which is defined. Or for example, you want to define the total sales is the number of quantity being sold into the price per unit, and that will be the total sales. In the table, the data sits in one column as a number of quantity, and whereas in the other column, it sits as the price per unit, what has been sold, and the math has to be done. So normally in the SQL, we'll write it, but you can define it by yourself in your YAML file, saying that if a user asks this question, then it means that it is asking for this particular value. Again, the better the semantic layer, the more the context it has the better, the more accurate the results comes in. You also define the conditions like filters, where you can limit the data that don't go haywire and look for data for last 4 years. Our result set will always look for data for last 6 months to keep the cost in little bit in control, and then gradually you expose it. You define the joins that if you're defining a fact, a star schema, then you define that there is a product ID key which is present in the fact table, and that is the join based on these two tables can correlate to each other. So with that information present in the semantic view, it helps when the user asks the question to understand what is present and what query has to be executed against. There is a concept in Snowflake Cortex analyst is to verified query. Suppose a query has been asked, what was the example what we saw, that what is the total amount of sale, and that query has been, the same question has been repetitively asked for like 10 times or 15 times by different users. In your dashboard as an admin, you can see, or the analyst who are using that, building that's helping to build the semantic model, can say that this query has been asked multiple times. This is a true query. This is an authentic. It gives the accurate results. Mark it as verified query, and that information get feeded back to the semantic model. And that is a feedback loop in the AI, which is a much more challenging nowadays. That it's not happening. But in a Snowflake, you can feed back all your verified queries or mostly queried prompt to your semantic model, and which improves the accuracy of the data, as accuracy of your prompts and the result as we make a progress. We give custom instruction like business-specific guidance for query generation. Example, use net revenue when user asks for revenue. So there is a column in your table which is a net revenue, but user is always asking revenue. Then how do the model know? You define this business terms and the glossary that this one particular column has 10 different synonyms. For example, a customer ID can be a member ID, can be a user ID, can be a customer ID itself, or an ID column in the table. If you define all this context in your semantic model, when the user asks even that, give me all the IDs, it understands that the user is talking about customer ID in this case, or a member ID in this case. And Cortex Search Service, which helps us to maps the input like product name to correct data values. In this example, if you see on the screen, it says about iPhone 13. User asks about iPhone 13, which is mapped to product name like Apple iPhone 13, which is in the table using a Cortex Search Service. And this is the whole architecture in which the Cortex analyst works, that the user asks the question on the prompt, and the data sets. So the first, it do not directly come and hit the database. With the YAML or the SQL semantic view which is built, the question is being passed to the REST API, and from there it is being question is to understand that can this be answered, and if it can be answered, then the multiple parallel model runs in this to classify and enrich the extract and generates the questions, generate the SQL generated for this. And when they generate the SQL, they work with like more than one models running in parallel. If the query is having errors or syntax, they keep improvising it until they synthesize and get a proper curated query which can be run against the database. And that response goes back to the REST API. And from there, that query gets executed on the database, and then the results comes. So this REST API is something which I say that the interface to this whole Cortex analyst, it need not be from a Snowflake. You can even use this from your external application, like any interface which you have built to talk to this REST API agents using PAT tokens or something, which can still not make the data move out of Snowflake, but it can and do not gives proper guardrails in terms of governance, and that can work out. So for us, when it came to this challenge and this was asked, like, how can we do it? We started with the phase one for us was to build the proof of concept. It was like we built a very simple text to SQL Cortex LLM functions, a schema context injection where we provided that this is the schema, this is the columns, these are the tables. And we built a very simple Streamlit interface using a Streamlit application, which was taking the prompts for the user. And that Streamlit app was shared across a set of limited users. And we started very small. We worked with like set of like 3 to 5 tables to start querying so that it gives an answer to this. One good thing with Snowflake or any of the tools present in the data technology present, that you don't have an upfront investment if you are not having your own. So you pay for what you use. And that is something is like in the world of AI, the way we see that you evolve First, you iterate and you start small always, and then you make it better, and then you expand it. So for us, the early wins was like we got a simple 60% accuracy on simple questions. The stakeholders' excitement was pretty high that, yeah, we have done it, and this is looking good, we are working. And it was a quick validation of the concept that natural language processing is possible. But it's not always, something didn't work for us. There was lots of technical challenges in that ambiguous questions led to wrong queries. Suppose a finance guy is asking that total revenue and he is getting 10 billion, whereas the revenue is 1 billion, and he's using it to show it in his quarterly result. That will be a nightmare, right? So modelers struggled with complex join when the people started asking complex questions, like in the previous talk, the people present over here. They were asked, a big question was asked, and if you don't have a proper semantic layer, that question would have a struggle and it was not working. There was no way for us to handle a follow-up question, like it was not able to open-ended what we said that in the Cortex world, you have an open-ended, you can keep asking follow-up questions on top to keep the conversation going. That was not there. And there was a performance issue for us with a large result set. These were the technical challenges which we were facing, but there was business challenges as well. User expected perfection immediately. They wanted that, I want it now, and this has to be perfect. It has to be 100% accurate. Lack of trust when the result looked off. I said that end user started sending queries back to the analyst. Can you evaluate it because this is looking wrong? And as you see, the query which gets generated by the AI is not like a human written query, because human written query is much more knowing that it may be shorter, it may be optimal on performance. But when it comes to AI, it is like 500 lines of query, which takes time for analysts to understand, because it's not written by them first thing and they to get the context. And need for result explanations. So people were looking like how this result is looking, why this number has come. So what we did, like we take to the second phase, what the learning we had, and we iterated further on that. And what we did on in terms of technical enhancement, that prompt engineering with examples. We gave some sample questions to be fed into our semantic model. Few short learnings, we did that. Semantic layer for business logic with all like net revenue, how it looks like, what is the number of, when people say stores, it is a location in our dimension. It is not, we don't have a table called store, but we have a table called location. So that's what it meant. Feed in verified queries from the previous runs. It was not possible in the first iteration. Snowflake didn't have that feedback loop, but now they have introduced that. So you can feed back your verified queries to your semantic model, and you don't have to do it manually. It goes by itself. A business-specific guideline for query execution. With this, we had a good results. For the simple queries, our performance jumped from 85 to 95%, like that in the range. And for complex, it was like 40%, it again went to 75%. Still not 100, still not 100% accurate, but it was something much more reliable for simple queries. Results were coming pretty good. And that's the phase we are in. We are still not say that this is 100% accurate. Still we are evaluating, we are still iterating on that. And with this, the way of the implementation to the production, we saw that there were lots of unexpected common edge cases which we all saw, that vague questions were being asked, like in the question, show me sales. But no context was provided or no prompt was provided in terms of like which period of sales, which reason, which location, the sales for what. Impossible request like data not in warehouse. That's something which is a challenging one. Security, user asking data for the data they can't access. And they believe when they open the world of this AI that they can query anything inside of Snowflake. But because of, thanks to Snowflake governance, that and the security protocol, that they are not able to access something which they are not supposed to. And that something is really good. Keeps our life safe in terms of our job safe as well, because if a data leakage happens, it happens through that channels. And lots of ambiguous metrics, different definition of revenue. For sales team, this revenue is something different, whereas for the finance team, revenue is something where the check has been encashed and the money is in the account. But for sales team, it is the target. They have made, they have blocked the sales, the engagement is going on, and that's their metrics. So these were like very common edge cases which were being done. And the way we handled it and tried to set the explanation was clarifying questions before query generation. So we were asking the questions back. graceful error message in terms like if you don't have access, okay, this user you don't have access to this data sets. Your role do not get to go get an admin approval to change your role. Row level security enforcement, that's very actively done across the whole of our ecosystem at Snowflake. And we have introduced a lot of Snowflake Horizon catalog, or Snowflake Horizon to tag all the data sets, which helps us to identify pretty easily that this data do not have access. This role do not have access to this data sets based on the tag. And business glossary integration, which we use a tool called Atlan to integrate it, so which is a feedback loop, both bidirectional. The end users, the end user who generates the source team which generates the data sets, like in our case, GitLab.com itself generates a heavy data. They define each and every column what it means. We are educating and we are putting a lot of pressure that we get that thing, all the context set from the source, and that data gets fed through Atlan to a Snowflake, which helps us to build the semantic layer much more smoothly. Monitoring in Cortex Analyst, it's continuously logs every user interactions to help administrators to improve the quality and accuracy of the model. Snowflake provides an out-of-the-box, like, and you can see, you can run a query, which is like a lag of 1 or 2 minutes against the event table in Snowflake, which gives you that which user asked the question, what questions was being asked, generated SQLs, and if any error, then what was the error and warning, and request and response, what was being provided, plus the metadata. Log updates every short delay of 1 or 2 minutes, but yes, it is there. This is like the simple it looks like, where we have logs can be viewed in a Snowsite. That's the UI of what we call in a Snowflake. What is daily sales? So like the question which I asked, this was interpreter output and like that, and the feedback. And this, if this daily sales is like something is a verified query, we feed it back to our product, the semantic model again. And a different way to integrate this whole Snowflake Cortex is that Snowsite, which is a conversational UI, which itself where we have run our Streamlit application, REST API from embedding in apps. We also have this working with Slack, so you can ask question from Slack to a Snowflake. Role-based access via RBAC and end-to-end observability pipeline to be done. And the business adaptation journey for this was, first we did the concept validation. It was a very small internal prototype to say that, okay, this can be possible, this will bring some meaningful result, it will save some time and energy. Pilot rollout, very limited business users. For us, we targeted people off Steam because that's a very internal data, it's not targeting finance. Semantic model refinement, improve the accuracy as we iterate further, and full deployment for broader access. So the phase 2 is a full deployment for us, but still in a progress because the accuracy is still not 100%, because none of the AI models say, they always comes with a disclaimer, use it on your own risk. So that's something that still exists there, and we are also working along with that. And feedback and training, that is to drive the adoption, tell people more to use it, and the more they use it, it makes the life easy. Lesson learned in terms of technical, start simple, iterate based on real usage, invest heavily on prompt engineering, because that's something, the better the prompts, the better the results comes in. Semantic layer is mandatory. It's not an optional thing in a Snowflake for a structured data. It helps a lot to get the better results. And monitor everything, query, errors, user satisfaction, which will help you to improve your model, and in terms helps you to improve your results coming out of this. And in terms of business lessons, set realistic expectation early, which is very tough with the end users, because people ask, like, I want it now, and I want it this awesome thing, which is, I want to use it. User training is as important as the tech, so we need to train the user. So we host a couple of office hours for every time we release something to help people that ask any question, what do this thing? And always celebrate your win, even though it is a small. This helps us to keep motivated, and also celebrate your failures. Because if you do it publicly, it helps you to get active feedback, and that helps us to go and improve and so on. Outcomes and benefit. Yeah, okay, yeah, just. So outcomes and benefit was democratizing analytics for all roles, reduce analytics backlog. That was something which was end users were keep sending for BI. There is a little bit reduction, at least from the people off side, what we do. Faster time to insight, consistent governance metrics, and improved collaboration between data and business. Our the tagline below is that our team's talks to date are not through tickets, because that has gone significantly down. The number when we see for the people ops team was like 50% reduction in terms of getting more requests. So that was this. And for the key takeaway from this is that conversational analytics is the next evolution of BI. That's what I see it, and everyone is seeing it with the talks we are seeing in this whole conference. A Snowflake Cortex is a AI native plus governed plus secured, so that makes our life. Start with one domain, use either revenue, sales, people ops, and expand horizon as you see the results. Build a trusted semantic layer, not just an LLM wrapper, because that will help you to improve. The best interface to the data is language itself. And that I would like to conclude my talk. Thanks for listening. This is me. If you want to, I'm available around. I'm till tomorrow. Any questions around this, how we have done it, please, happy to chat and explain around that. And this is me. You can reach out to me on the social media. And thank you. Thanks.
Thank you. Thank you so much.
And it's
Thank
open
you,
for
Ved.
questions if anyone.
Yeah. Is there any questions? There are two.
Yeah. Yeah. Forward. No, so we don't own the model, so we won't be able to retrain it. The way we improved it is that feeding back. So as said, the semantic layer is the brain. The semantic layer needs more and more context in order to give you a better results. So we keep updating. So as soon as a new context has been provided, that this particular column is also being known as this. So you feed back that, and a new updated semantic model gets generated for you instantly. Like in a Snowflake now, you can do. Yes, it gets feeded. So basically, it's taking feedback from your prompt. And from the prompt, once someone verifies that, OK, this is good, then it feedbacks. That loop was missing. And for AI, the feedback is one of the biggest thing I feel, that the more feedback, better it gets, and it improves. We don't go and train the model. That's something with Snowflake. It just sits in their horizon, and that's what we just use it. We don't train the model. Yep. They have this whole everything Yes, yes. So there is a human involved in mid who goes and look for a Snowflake gives you like a vectorized place where in the UI where you go and see that these are the most frequently asked questions, and then the user, the analyst, basically goes and approves that, yes, this is a verified query, and that goes and update the semantic model. So that makes it much more accurate. So because next time when the user asks, it's known that this is the question, the answer is 100%. That's how we have done it. Yes, sir. Okay, so semantic model in the way we have built is that we built a domain-specific semantic models. Like for people ops, there is one semantic models with like 20 tables, for example. And the final is prod layer, which is a clean data, transformed data. And it's basically the golden data, that's what we point towards the semantic model. If we find an issue with the prompt itself and it's not working, we definitely start from scratch. That's what I do, that I go and say, OK, this is a question, what would my answer look like if I have to write it? And what is missing in this prompt, which is not letting my semantic model evaluate it? Like, is it missing a context? Is there a column which is totally not defined? For example, unit is a column, but it says that it contains the whole item in the basket. For example, in a transaction, it has 20 items being bought, and that's a transaction line item in a transaction dim, for example. But it is treating it as one unit itself. It's not. So that's something, a mathematical expression, something is missing, and that we need to go and update in the semantic model, saying that this expression, when people ask about how many units have been sold, then treat this as a basket. Like basically, in a CPG or retail, there is always a partial basket transaction where people have bought something, then they came and refunded something, and then they again bought something. That's a partial basket, and that kind of concept helps creates problem for semantic model. We need to go and tell that what mathematical logic you have to use in order to say the total number of units sold. So that, again, we start with first, I do that way. People would have a better answers, but I start from scratch. I look at the question and start writing my own queries and see that, okay, but why this is not working? And if it is not working, it's missing an expression because this math I'm doing in my SQL query, which that query generated from the semantic Cortex analyst is not using that math. Then I have to feed it the semantic model, and that solves it.
Thank you so much. Once again,
you.
thank you, Ved,
Thanks a lot.
for your presentation. It was
Thank you.
great. Yeah, applause.
Thank you.
Thank you. Now is a coffee break till 4:45.